today our video is going to be about what defines an equation as a function. So the first thing is we've got to cover some vocabulary. The first vocab word is a relation. A relation is any set of numbers. And today what we're going to do is we're going to look at taking that set of numbers and we're going to map it. So our relation can be a mapping of inputs, and what you put into the equation is going to be that x value, and outputs, which is going to be that y value. So you put in the x, you take out the y. The domain is going to refer to all possible input values. All input values, which we just said is representing those x values. And another way to look at that is if you think back to your science class, the domain is going to be representing that independent variable. So if the domain is all possible input values, the range is going to be all possible output values. So that's going to be your y values, which means that that's going to be your dependent variable. And now finally to our vocab word, our focus of the day is going to be a function. What defines a function? A function is when you have exactly one output for every input. And I like to look at it the other way, saying each input value has exactly one output. So every input has exactly one output. Really quickly, one way to remember this is think about a soda machine. On a soda machine, you have different buttons. And if you hit the Coke button, you hope that when you hit Coke, out comes a Coca-Cola. You don't want to hit a Coke and get a water. So every button, every input should always have the exact same output value. Every time you hit the Coke button, you should get a Coke. Every time you hit Mountain Dew, you should get Mountain Dew. But sometimes you can have the same input giving the same output. So if, let's say, Pepsi is a really popular drink, you may have two buttons for Pepsi, but every time you hit the Pepsi button, it should still give you Pepsi. All right, so let's look here. Let's kind of look at this in the equation world. We have our warm-up. Complete the table for each function rule. So we are going to be plugging values into our equation. These are our given x's. So 4x minus 1, we want to find out what is that value when x is a negative 2. So 4 times a negative 2 minus 1, negative 8 minus 1, negative 9. 4 times a negative 1 minus 1, that's a negative 1 minus 1, a negative 5. 0. 4 times 0 minus 1, negative 1. 4 times 1 minus 1, 4 minus 1 gives you 3. So we inputted all of those x values to get those output values. And what's that doing? That's creating a mapping of those inputs. So this is what we know. Let's do it for our other equation. So we have negative 2 squared minus 1. And we reviewed that when we square a negative, it becomes a positive. So negative 2 squared is a positive 4. 4 minus 1 gives us 3. Negative 1 squared minus 1. 1 minus 1 is 0. 0 squared minus 1, negative 1. And 1 squared minus 1 is going to be 1 minus 1, which gives us 0. So we've mapped those values. Notice how we had 0 come up twice. That's okay. That's kind of like on your soda machine. If you have two different buttons representing the same thing. But every single time we put a -1 in, we better get 0 out. Every time we hit 1, we're also going to get 0. That's okay. But I can't put a -2 in and get a -9. That wouldn't be functioning properly. So if we look at the mapping of this, when I plug in 1, I get 3. When I plug in 2, I get 6. When I plug in 3, I get 6. When I plug in 4, I get 9. Yes, this is a function because every input is going to have exactly one output. It can be the same output, that's okay, as long as every time you hit 2, you get 6. Every time you hit 3, you get 6. Where things start not functioning correctly is when I look at the next one. One time I put a -5 in and I got a -6. The next time I put a -5 in, I got an 11. That tells me that this is not a function. It's not functioning properly. Every time you put a value in, you should get the same value out every single time. And the next one, we're looking at the exact same thing, but we're going to look at it as a table. A table is just another mapping. A table is what we created up here. So if it's easier, what you can do is you can create a mapping. So I see that my x's are 2, 3, 4, 5. 2, 3, 4, 5. When I get a 2, it maps to a 4. 3 maps to a 6. 4 also maps to a 6. And 5 maps to 10. Remember that this right here is okay. We still have a function because 3 is going to give us 6 and 4 is going to give us 6. Two different buttons can give us the same answer. That's okay. But when we go to the next one, we have our x's are 2, 3, and 4. When I plugged in a 2, I got a 4. When I plugged in a 3, I got a 6. But the next time I plugged in a 3, I got a 7. That's where my problem is going to occur. This is not okay. When I plug a 3 in, whatever that value is for 3, it should be the same value of 3 every single time. All right, so now what you're probably familiar with is the vertical line test. The vertical line test, you probably maybe also heard it as the pencil test. This determines whether or not it's a function. If you can draw a vertical line, no matter where you draw it, everywhere you draw it, so this is why we call it the pencil test. If you were to take your pencil and just carry it across your graph, it can't hit more than one time. If it never hits more than one time, then yes, it's a function. Now, if I were to do my pencil test or my vertical line test right here, that passes, but it doesn't pass the test because at one point, when you draw that vertical line, it's going to hit more than one time. So this is not a function because it fails the vertical line test. No matter where I draw it on my last graph, it's never going to hit more than once. All of those different things that we just did were all different ways to determine whether or not it's a function. All right, let's turn on over to the back side. And then we have function notation, so how you're used to seeing it. So in Algebra 1, you learned about function notation. Hopefully, maybe, this is why we have our unit 0, because sometimes depending on your Algebra 1 class that you took in junior high, maybe you covered it, maybe you didn't. So we're going to kind of get everybody here on the same page. We want to rewrite the equation in function notation, step 1. This is actually really easy. See this y equals? To change it to function notation, all I have to do is change the y to f of x. Step 1 is done. Step 2, complete the following table given function notation. Make sure that you choose x values that make it an integer. So now this right here goes back to our PowerPoint when we had all those different vocab words. So if I'm going to choose it as an integer, that means I want to get rid of the decimals and the fractions. When I look at this equation, it's something times x is 2/3. To get rid of the fraction, all I have to do is multiply it by multiples of 3. whatever that happens to be. And notice that you have choices here. It doesn't have a table filled out for you. So you could really choose any 4 points that you want. It's up to you as long as it's a multiple of 3. So let's say I did 3, 6, 9, 12. That does not have to be the 4 that you chose. So if I started here, 2/3 times 3 minus 4. Those 3's cancel. 2 minus 4, that's a negative 2. 2/3 times 6 minus 4, that becomes a 2. 2 times 2 is 4. 4 minus 4, 0. 2/3 times 9 minus 4. Notice how I have not used a calculator at all. Don't rely on your calculator too much. 2 times 3 is 6. Minus 4 is 2, and maybe you notice the pattern. I'm going up by 2 every time, so maybe you don't even want to plug it in the last one. You know what it is. So step 2, done. Our last one, sketch the graph. The key word here is sketch. If I give you a 10 by 10 grid with lines, you have to plot exact points. But here I'm just sketching it. So if I look, I'm at 3, roughly negative 2, 6, 0, 9, 2, 12, 4. And here's a rough sketch of that equation. It's asking me, is it a function? The easiest way we can do this, well, at least what I think is the easiest way, is that vertical line test. No matter where I draw it, I'm always going to have it only go through one time, so therefore, yes, it does pass that vertical line test. You could have also created a mapping of your table, completely up to you. All right. Now, why function notation is so helpful is because it gives you more information about your graph itself. If we think, let's just go back up 1 second. If we look back here, when I plugged this in, this was representing the f of 3. I plugged 3 in for the place of x, and I got out the y value. So remember, the number in parentheses is the number that you are plugging in for x. Use the graph below to find the values asked for. Finding f of x, so whatever number you plugged in for x, is like finding the y value. So if I'm looking at part A, it says find f of negative 6. That means that my x value is negative 6. Don't forget that the x's run left and right, and the y's run up and down. Sometimes we forget to think about things in terms of x and y. So that means I'm going to be going left 6. When I go left 6, I want to see, where is my graph at that point? This is where my graph is existing when x is a negative 6. If I look at that, I see that it has a y value of 12. So when x is a negative 6, my y is 12. If we go over to B, find f of negative 3. So remember, that means I'm looking left 3. So from 0, left 3. Oh, look. My function is on that axis right there. This coordinate is negative 3, 0. So f of negative 3 is 0. Part C, f of 0. So that means x is at 0. Here's where my x is at 0. Where is my equation existing at x? Oh, here it is. That point is at 0, negative 8. D, f of 2. So that means we're going to go right 2. Here's 2. Here's my graph. So I'm at 2, negative 10. So when x is 2, my y is a negative 10. F of 8. Here's where my x is 8. Our graph is crossing right there, so this is at 8, 0. Now our last one, a little bit different. Notice that I'm saying f of x. I don't know where my x is. I'm not given my x value. I am given my y value. So I want to find out what is x when my y is 0. And y is your movement up and down. So if I'm going up and down, everything along here is going to have a y value of 0. So we're actually looking for our x-intercepts because x-intercepts are always when that y value is 0. It's here, here, where else is it cross, and there. So we don't really have a number here, so just for sakes right now, I'm going to make that a -9. It's also crossing at a -3, and it's crossing at a +8. So the key for that last one is just remember the number in the parentheses is the x, the horizontal movement. The number that you take out, the output, is the y, the vertical change. All right, and that is it for this video.